Section 1.2 is powers and exponents. I can use powers to describe repeated multiplication. A power is the result of a repeated multiplication of the same factor. Remember, factors are things that we multiply together. So for example, the number 125 is a power because 125 is the exact same thing. It's equal to 5 times 5 times 5. So the same number multiplied by itself. A power can be written in a form that has two parts, a number called the base and a number called the exponent. So the exponent shows the number of times the base is used as a factor. In the example above, 5 is our base, it's the number being multiplied, and our exponent here is 3 because we have 1, 2, 3 5s in a row. And that equals 125. So another way of writing 125 equals 5 times 5 times 5 is 5 to the third power, or 5 cubed, writing it as that power. Again, the 5 is the base, and the 3 is the exponent. So in example 1, we're going to use exponents. It says write a product using an exponent. So here, our base is this number that's being multiplied every time, our factor. It's the same every time, 13, so that stays our base. And then our exponent is how many times it's been multiplied. Here we have 1, 2, 3, 4. So we have 13 to the fourth power. In B, my base is 0.2, 0.2. It's a thing that's being multiplied every time. And I have 3 of them, which means my exponent is 3. In C, it works the same way, even though we have a variable here. So I have n every time is what's being multiplied, so that's my base. And my exponent is how many of them I have, which here is 6. So this is the same as n to the 6th power. And in D, same idea. My base is the thing that's being multiplied every time, that factor. And my exponent tells me how many times that factor's been multiplied times itself, which here is 5, so I have t to the 5th power. Feel free to pause here and give this a try with the checkpoint. We're going to write the product using an exponent. So for number 1, my base is 10. It's being multiplied 3 times, so 10 to the 3rd power. Number 2, my base, they're both the exact same, so it's going to be 4.3. My exponent is how many times it's being multiplied, which here is 2. So here we can say 4.3 to the 2nd power, or 4.3 squared. Try 3. Here my base, every time, is the same thing. It just happens to be x. And the number of times that base is being multiplied, that factor, is 4. So my exponent becomes a 4. In example 2, we're evaluating powers with variables. Here we want to evaluate the expression x to the 4th power when x is 0.5. So every time I see an x, I'm going to plug in a 0.5. And here I have an x. So I have 0.5, and it's still being raised to the 4th power. Now we can work backwards from what we did in example 1. We can write this as repeated multiplication. We can take our base times itself, exponent number of times. So I'm going to take my base times itself 4 times. Okay, and from here I can go ahead and multiply. 0.5 times 0.5, 5 times 5 is 25, and we have 2 decimal places, so 2 decimal places, I get 0.25. Times 0.5 gives me 0.125, and times 0.5 gives me 0.0625. Again, we have 4 decimal places, so I need 4 decimal places in my answer. If we wanted to, we could have done this 2 at a time, so I could have gone 0.25 here, 0.25 there, and then multiplied. Either way. Checkpoint here. We're going to try when m equals 3. Give this a pause and give it a try. So everywhere I see an m, I'm going to plug in a 3. So I have m, which is 3, and here it's squared. I know that I can write this with repeated multiplication. I can take that base times itself, exponent number of times. And then I can simplify. 3 times 3 is 9. So when m is 3, m squared is 9. Try 6. Again, we say m is 3. So everywhere I see an m, I'm going to write a 3. And then the rest of it here is cubed. I can rewrite this as repeated multiplication. 3 times 3 is 9, and I still have a times 3 there. 9 times 3, 27. M is still 3 here, so give 7 a try. Everywhere I see an m, I'm going to make a 3. So I have 3, and it's still to the 4th power. I can write this power as repeated multiplication. So I'm going to take my base, 3, times itself, exponent number of times. And this is what I was talking about earlier with the 0.5s. If we wanted to, we can multiply in any order. So I can take 3 times 3, which is 9, and 3 times 3, which is 9, and then multiply to get to the 81. Or I could have done 3 times 3, 9, times 3, 27, times 3, 81. Either way, we get to the same spot. And in 8, m is 3. So everywhere I see an m, I'm going to write a 3. I still have to the 5th power here. So first thing I'm going to do is I'm going to write this out as repeated multiplication. I have 5 3's because it's to the 5th power. And now I am going to simplify. 3 times 3 is 9. 3 times 3 is 9. And I still have that last 3. 9 times 9 is 81 times 3. So if I go over here, 1 times 3 is 3. 8 times 3 is 24. So I have 243 as my answer. A formula describes a relationship between quantities. Some formulas involve powers, such as area of a square and volume of a cube. So for example, the area of a square is A equals side squared, S squared, and the volume of a cube is V equals S cubed, where S is the side length. So in example 3, we're going to use powers in formulas. An artist uses a cube-shaped block of ice to make an ice sculpture for a competition. Find the volume of the block of ice if the side length is 20. Well, here we are looking for find the volume, so I'm going to use the volume of a cube, and it told me it's a cube-shaped block of ice. So my formula is V equals S cubed. S stands for side length, and here it tells me my side length is 20. So instead of an S, I'm going to write a 20. I'm still looking for my volume, and it's still cubed. So here we know that we can take our base times itself, exponent number of times, and then we can simplify. 20 times 20, 2 times 2 is 4, and then we have a 0 and a 0, so 400 times 20. And then I can take 4 times 2, which is 8. We have 1, 2, 3 zeros. So 3 zeros. This is in inches. And since we took inches times inches times inches, labels work the same way. I can take my label, 1, 2, 3, cubed. So 8,000 cubic inches is my volume. Feel free to pause here and give this a try. We want to find the area of a square with the given side length. Remember, our formula for area of a square is A equals side squared. So give 9 a try. Here it says our side length is 9, so everywhere I see an S, I'm going to plug in a 9. And I still have an A equals, and that 9 is still squared. Again, we can rewrite this as repeated multiplication. 9 times 9. And it's squared 2, so we have 2 of them. Gives me 81, and this is in meters. Remember, I have meters and meters, so just like with my 9s, I can write it as meters squared. Area is always in square units. Try 10. Again, our formula is A equals side squared. Everywhere I see side length, though, I'm going to plug in 11. And then I bring everything else straight down. So I have A equals 11 squared. Here I have a power, which means I can write it as repeated multiplication. I take my base times itself, exponent number of times, and then we can simplify. Gives me 121, and this is inches squared. Because just like I had 11 times 11 and I wrote 11 squared, I had inches times inches, so I write it as inches squared. And 12. Here my formula is A equals side squared, but I know that my side length is 1.5, so I plug 1.5 in for my side length. Everything else stays the same. And we write it as repeated multiplication. Okay, 15 times 15 is 225. But here I have 2 decimal places, so in my answer I need 2 decimal places. So I get 2.25. My label here is centimeters times centimeters, so centimeters squared. And that is all I have for section 1.2.